Welcome to this explainer made by Forge College. So, in our last lesson, we finalized our deployment checklists. Now, it's time to bust out the blueprints for state management. Look, nobody likes paying unnecessary gas fees, right? It's literally like paying rent for a room you never use to a landlord you've never met. Today, we're going to explore how complex data structures dictate your on-chain state and, well, how to stop bleeding Ethereum every time your contract breathes. Let's just jump straight into our core mental model here. We need to stop scattering random variables throughout our code like dirty laundry. Instead, we absolutely have to embrace this golden rule. Treat Solidity contract state like a minimal append-only database schema. Your smart contract lives in a world of highly deterministic and incredibly expensive storage. By planning a database schema first, you essentially force yourself to build this optimized, gas-saving foundation before you write even a single line of logic.
Okay, so here's our agenda for today. We'll be covering state management and gas, the minimal database schema, nested mappings unpacked, structs and structure packing, and finally, structuring user balances.
Section 1. State management and gas.
Before we draw up a single line of code, we really have to respect our building materials. State management is this rigid design discipline. It's the art of actively choosing exactly what to save, how to organize it, and how it lives and dies over time, because, every single piece of data you save has weight. You absolutely have to ruthlessly weigh how often you'll read it, write it, and who's actually allowed to touch it.
And this brings us to the fundamental trade-off in Solidity. Computation, it's cheap. But persistent storage, those SS store operations, man, that is like buying luxury real estate on the blockchain. If you're storing redundant data or doing 5 separate storage writes when you really only needed 1, your users are going to pay the ultimate price in gas fees. We've got to keep it minimal.
Section 2. The minimal database schema.
All right, let's head to the drafting table. To do this correctly, you're going to make 3 highly practical choices early on. First, identify entities. Basically, what actually exists. Are we talking users, assets, votes? Second, define relationships. How do these entities connect? Are they simple mappings or complex webs? And third, map operations. What queries do you actually need to execute cheaply? Your daily access patterns will completely dictate how your house is built.
Section 3. Nested mappings unpacked.
So, let's zoom in on our first core tool, the nested mapping. Imagine mapping a user to a token, and then to a balance. Mechanically, what Solidity does is it hashes these keys together to find a storage slot. It's kind of like a giant hotel with infinite rooms, but the beauty is you only pay for the specific doors you actually open. Because they are delightfully sparse, nested mappings give you lightning-fast access times without wasting space on empty entries.
But here is a major warning. Because those hotel rooms are hashed and scattered randomly, you cannot easily list them out on-chain. If you suddenly need to enumerate all of a user's holdings, well, you're essentially building a house without a floor plan. To fix that, you'd have to build a totally separate registry, which obviously means extra writes and extra gas. Not ideal.
Section 4. Structs and storage packing.
Okay, our second architectural tool helps us clean up the clutter, and that is struct packing. Think of packing like cramming your socks into your shoes so your suitcase actually closes without triggering those airline baggage fees. By grouping related, small value fields together in a very specific order, like say putting small integers and booleans tightly together, Solidity can fit them all into a single 32-byte storage slot. It's a massive discount on your storage costs.
These best practices are your structural reinforcements. Number 1, order by size. 2, always add new fields to the very end of your struct. This prevents absolute chaos during upgrades. 3, use versioned indirection. And 4, group your role checks with frequently accessed flags. Seriously, we constantly see developers save themselves massive headaches, not to mention corrupted storage, just by strictly adhering to these alignment rules.
Section 5. Structuring user balances. Let's look at a concrete case study to pull this all together. Let's say we need frequent reads, occasional updates, and rare enumeration for off-chain reporting. Option A is a flat nested mapping. This gives you super cheap lookups, but absolutely zero enumeration. Option B is a struct with an array of token IDs. That's great for enumeration, but it's an absolute gas nightmare every single time a token is moved. You kind of have to pick your optimization here.
But actually, there's a brilliant third path, which is the hybrid approach. This method pairs a nested mapping for fast reads with an optional index. What we're doing is delaying that massive gas cost of indexing by offloading it strictly to the specific workflow that actually needs to enumerate on-chain. Everyday users get cheap interactions, and the power users pay for the luxury of enumeration. It's a really gorgeous engineering compromise.
Section 6. Key takeaways. All right, let's roll up these blueprints.
First, treat your state as a rigid database schema. You really need to plan it out before you code. Second, prefer sparse nested mappings when you don't need enumeration. Third, ruthlessly exploit struct packing to squeeze data into single slots. And finally, favor delayed indexing so your everyday users aren't footing the gas bill for heavy features they don't even use.
So, I want to leave you with this provocative question to think about. Where in your current smart contracts are you needlessly performing multiple sload or ss-store operations in a single function? Seriously, go audit your code today. Bring those examples to our next lesson. And in the meantime, make sure to visit Forge College to dive deeper into this subject and master more Web3 engineering concepts. Keep building, stay frugal with your gas, and I'll catch you in the next explainer, made by Forge College.